Oscilloscopes are devices that allow you to visualize very fast changes in voltage over time, especially those that are too difficult to accurately track when using a multimeter. This is represented by a line from one side of a screen to another, which represents a graph of voltage on the y-axis and time along the x-axis. Oscilloscopes come in analog and digital varieties. Though the controls available on either type tend to be similar, they all have typically the same basic controls in common. All oscilloscopes typically have these controls: at least one input where an oscilloscope probe or coaxial cable can be attached, a screen with a grid overlay, a volts division control that allows you to adjust how many volts are represented by each vertical increment of the grid overlay on the screen, which works similarly to a zoom function in and out of the y-axis, a time division control that acts similarly to the previous control, but for the x-axis instead of the y-axis, a vertical position offset that allows you to move up and down in the y direction, a horizontal position offset that allows you to move left and right, and a trigger level that allows you to stabilize the waveform displayed on the screen. Begin by powering on your oscilloscope. If nothing else is plugged into it at the time, then you should see a flat line, which indicates that the voltage of the input is not changing over time. To begin, use the volts division and vertical position controls to center the horizontal line on the screen, and set the volts division to around 1 volt and the time division measurements to around 1 millisecond to start. To proceed, you will now need a steady signal of constant frequency. If you have a waveform generator, you can set it to a pulse or square wave with a 2.5 volt amplitude at 500 Hz. Now, plug the coaxial cable into the oscilloscope. Connect the center axial portion of the cable to the signal, and the outside, typically an alligator clip, to the ground. Set the oscilloscope for AC coupling. Once you have connected your signal, you should see the flat line turn into a waveform pattern. Adjust your time division setting so that you can see the separation between the oscillations, and adjust the volts division and vertical position so the waveform oscillates within the limits of the screen. When turning the trigger level dial, you will see a trigger level indicator move up and down on the screen. You may notice that when the trigger level exceeds the height of the waveform, the signal becomes unstable. This trigger level essentially acts as the level of voltage that your oscilloscope will compare the incoming signal with, allowing it to stabilize a repeating wave shape or capture voltage spikes on screen. Set your trigger level to center of the screen before moving on to measuring amplitude in the next step. The amplitude of the wave is the difference between the height of the peaks of a wave and the wave's equilibrium. Centering the wave to oscillate around the horizontal grid line allows you to see the peaks and valleys of the waveform accurately represented. Related to amplitude is frequency, which is the measure of times per second that a wave repeats its shape. We cannot directly measure the frequency of a wave on an oscilloscope, but we can measure a closely related parameter called a period, which is the amount of time that it takes to complete one full cycle. For example, if one cycle is completed in 2 horizontal grid divisions with a time division setting of 1 millisecond, 2 divisions equals 2 milliseconds. You can then use the relationship frequency of one period to calculate that in this scenario. The period of the signal is 500 cycles per second, or 500 Hz. You can view our full selection of oscilloscopes and more at galco.com.